Alright, so today we're just doing some extra review practice, some different types of problems. So if y equals x over e, then dy dx equals 1 over e. Is this true or false? So pause the video, think about it, unpause when you think you know your answer, and have an understanding on why that's your answer also. Obviously there's a 50-50 shot. You could just guess and get it right or get it wrong. I would recommend trying to understand the problem. E is the number e. So pause the video, think about it, unpause when you think you understand. Okay, so this is true. And this should make sense because e is a constant. So y equals x over e is the same as 1 over e times x. And whenever we take the derivative of, if I had g of x equals 2x, then g prime of x equals 2. So the derivative of a constant times x is just the constant. Next one. What is the slope of the curve y equals x to the fourth minus 3x squared plus 3 at negative 1, 1? Pause the video, unpause when you're ready to check your work. Alright, so y prime of x is 4x cubed minus 6x, so y prime of 1 is negative 1. Y prime of negative 1 is 4 times negative 1 minus 6 times negative 1, which is negative 4 plus 6, or positive 2. So that is the slope of the curve at that point. Okay, draw an approximate graph of the derivative of this function. As usual, there are many correct answers, however there are certain things that must be true. So draw what you think is a graph of the derivative, unpause when you're ready to check your work. Okay, so the derivative should look something like this, where the key features are that I know it has a 0 at this point and a 0 at this point because the function has a maximum and a minimum at those 2 points. I know that the derivative is positive in between the 2 zeros because the function was increasing in between the 2 zeros, and I know the derivative is negative outside of those 2 zeros because the function was decreasing outside of those 2 zeros. Let's try it again. Draw an approximate graph of the derivative of this function. So again, here's the regular function, draw the derivative. Pause the video, unpause when you're ready to check your work. Alright, so again here the key features are that we should have these zeros where the function had a minimum or a maximum. And then where the function is increasing, the derivative should be positive. So here the function is also increasing, here the derivative is positive. Where the function is decreasing, the derivative is negative. Where the function is decreasing, the derivative is negative. Alright, next example. I want you to find an equation of the line that is tangent to the graph of f and parallel to the given line. So here's the function, here's the line that we're going to be parallel to. Find an equation of the line that is tangent to this function and parallel to that line. Pause the video and pause when you're ready to check your work. Alright, so I know the slope of the tangent line is going to be 4 because that's the slope of the line that I want to be parallel to. So I find the derivative, f prime of x is 2x, and I set that equal to 4 and solve for x to find where does that slope occur. That occurs when x is 2. So then I figure out what is the y value when x is 2, so f of 2 is 2 squared plus 1, which is 5. So now I can write my equation of the tangent line with a slope of 4. So y minus 5 equals 4 times the quantity x minus 2. Next one. So the table shows some values of the derivative of an unknown function f. I want you to complete the table by finding, if possible, the derivative of each transformation of f. So I'll go through the first one together with you. By together, I mean I'm going to do it and you're going to listen since we're not actually together. So if I know these values of x and I know f prime of x for those values, how is g prime of x going to relate to f prime of x if g of x is f of x minus 2? So think about what kind of transformation is the minus 2? Well, all that's doing is that's a vertical shift. It's going to take f of x and shift it down 2. But that's not going to affect the slope of a tangent line at any point of f. It's not changing the curve at all. It's just shifting it down 2. So g prime of x is going to be the exact same as f prime of x for all of these locations. So I want you to take that idea and try to figure out B, C, and D. Now you'll get to some of these where you're not going to be able to find the value because of how the transformation, because of what the transformation is. So you just leave those blank. So pause the video, unpause when you're ready to check your work. Alright, so we know g prime of x equals f prime of x. So we did that one together. So how does h prime of x relate to f prime of x? Well, if h of x is 2 times f of x, because 2 is a constant in front of the function, h prime of x is 2 times f prime of x. So I just take all of the f prime of x values and multiply them by 2 at the given x value. So this is going to be h prime of negative 2 is 8 because f prime of negative 2 was 4. H prime of negative 1 is 4/3 because f prime of negative 1 was 2/3, and so on. How about r prime of x? Well, if r of x is f of negative 3x, then r prime of x is f prime of negative 3x times negative 3. That was the chain rule. Now, you'll notice that we can't get most of the r prime of x values then. That's because most of the f prime of values will be outside of the information that we're given. So it's not that they don't exist necessarily, we just don't know what they are. So for instance, if I wanted to find r prime of negative 2, well, I'd substitute in a negative 2 right here, which makes this 6. So it becomes f prime of 6 times negative 3. But I don't know what f prime of 6 is because 6 is outside of the domain of this table. So I can't solve that. But r prime of negative 1, if I plug in a negative 1, this becomes positive 3. I know f prime of 3 is negative 4, so times negative 3, I have negative 4 times negative 3, and that gives me 12. I can do the same thing for 0. I didn't show that work, but you can plug in 0, and we know f prime of 0. But then after that, then again, we're going to be outside of the domain of the table. So we're not going to be able to get 1, 2, or 3. How about s prime of x? Well, s of x is f of the quantity x plus 2. So again, using the chain rule, s prime of x is f prime of x plus 2 times 1. So the 1 doesn't really affect the problem. So all this is saying is we're just going to shift all the values over 2 to the left. So s prime of negative 2 is actually the same as f prime of 0. S prime of negative 1 is the same as f prime of 1. And so on. And so I'm able to get s prime of negative 2, negative 1, 0, and 1, but I can't get 2 and 3 because now s prime of 2 would equal f prime of 4. And I don't know f prime of 4. So that's why I had to leave these two blank. So again, the point of this problem is just to make sure we really have an understanding for how one function can relate to another function, and then how that affects how the derivative of the one function relates to the derivative of the other function. Alright, that's the end of these review notes. Have a good night.